All right, let's talk about building systems with microservices. You're always chasing two things, right? You need to be incredibly fast, but you also have to be completely correct. It's a tough balance. Today, we're going to dive into a really powerful technique that helps you nail both, the barrier pattern. So, picture this. You're building an e-commerce product page. To load that page, you need to get the price, the inventory, and the customer views from three totally separate services. Now, if you call them one after another, serially, that page could take, say, 900 milliseconds to load. Yikes. But what if you call them all at the same time? Well, with the barrier pattern, you're looking at maybe 300 milliseconds. That's a 3 times speed up just like that.
And look, this isn't just some technical number we're patting ourselves on the back for. That latency, that is the user experience. That 600 millisecond gap is the exact moment a user decides to stick around and buy something or gets frustrated and clicks over to your competitor. This stuff has a direct impact on the bottom line.
But here's the thing. Speed is only half the battle. The real magic of the barrier pattern, the thing that makes it so robust, is its core promise, the all-or-nothing guarantee. This is all about being reliable and earning and keeping your users' trust. This right here is the fundamental contract of the barrier. Your system will never, ever leave a user in a weird, confusing state. It's not going to show you a price and some shiny reviews, but then hide the add to cart button because the inventory service timed out. No way. You either get a complete, perfect, working page, or you get a clear, honest error message.
And this comparison really shows you what's at stake. You know, a more naive approach might just throw whatever data it got back onto the page, leaving the user with a broken, corrupted experience that just erodes trust. The barrier pattern, though, it protects that trust. If one little piece of the puzzle is missing, it opts for a single, clean error message, and that is so much better than a broken page. So how does it actually pull this off? Let's pop the hood and get into the mechanics. I want you to think about it like 3 lanes of traffic on a highway. Each lane is a call to one of our services. The barrier itself is kind of like a gate at the end of those lanes, and that gate absolutely will not lift until all 3 cars have arrived safely. Only then does the combined traffic get to move forward. So it's really just a simple 3-act play. First, we fan out. This is where we launch a separate worker for each service we need to talk to. In Go, we'd call this a goroutine. You can just think of it as a super, super lightweight thread. Second, each of those workers goes off and does its job all by itself. And third, the most important part, we aggregate. This is where we all wait at that barrier until every single worker has checked back in with either a success or a failure. And the beauty of this whole thing, it's how simple the communication is. We don't need a messy setup with one channel for good results and another for bad ones. Nope. We use a single unified result type. Every single worker sends its message back on the exact same channel, and that message just carries either the value we wanted or the error that happened. It's so clean. Okay, now this is the secret sauce. This is the big aha moment. We use something called a buffered channel, and here's the critical part. The size of that buffer has to be exactly the same as the number of workers we launched. And this is not for performance, this is a correctness requirement. It's what guarantees that even if our main function sees an error and decides to stop listening early, the other workers still have a place to drop off their results so they can finish their work and exit cleanly. Without this, they'd be blocked forever, creating a nasty bug called a goroutine leak. You know, any pattern looks great on a sunny day when everything's working perfectly, but what happens when things go wrong? Because in the real world, things always go wrong. A truly production-ready system has to be tested against the most common ways it can fail. So let's walk through the big 3. First up, the happy path. This is the easy one, right? It's our baseline. All 3 services respond, they respond quickly, and they respond with good data. The barrier just waits, collects all 3 results, and passes them along. Everything just works. Beautiful. Okay, but what if one of those services fails? This is where that all-or-nothing promise really gets tested. The second the barrier sees that first error come in from any of the workers, it's done. It immediately stops waiting and returns that single error. And this is so important. It throws away any successful results it might have already gotten. No partial data ever escapes. And finally, we've got to talk about the silent killer of distributed systems, the service that just never responds. It's just hanging. We can't wait around forever. That's why we have a timeout configured on our HTTP client. When that timeout gets triggered, the worker reports a timeout error, and the barrier fails fast, just like it did in the last scenario. And once you start thinking about these failure modes, success, error, timeout, you're not just a coder anymore. You're starting to think like an architect. You're realizing that a production system isn't just about making the happy path work. It's about gracefully handling all the ways it can and will break. And here is a piece of hard-won wisdom from the trenches. That timeout value we just talked about, don't you dare hard-code it. Making it configurable so you can inject it into your functions is one of those little things that separates tutorial code from a robust, testable production-grade system. This way, you can have a really long timeout for local testing and a much, much tighter one in production.
So, all of this leads to a huge question that you as the architect have to answer for your system. What is the right error contract for your users? The barrier pattern makes a very specific choice here, but believe me, it is not the only option on the table. The all-or-nothing approach that the barrier uses is absolutely perfect when data integrity is everything. But sometimes a best effort approach is okay. Maybe it's fine to show a product with a price and inventory, but just say reviews are unavailable. Or maybe you need a quorum, where as long as, say, 2 out of 3 services come back okay, you can move forward. The point is, choosing your strategy is a critical design decision. And that really brings us to the final thought I want to leave you with. When your system is under stress, when services downstream are slow or failing left and right, the patterns you choose will define what your user experiences. So, are you delivering a chaotic, broken, confusing page, or are you delivering clarity with a fast, understandable error? The barrier pattern is one of the best tools I know for choosing clarity every time.